Okay. So today, what I'm going to be doing is I'm going to be giving a kind of very brief introduction to difference and differences, yeah, also known as diff and diff, also known as DID. And what I'm first going to do is I'm going to motivate this under an experimental design, right? Under an experimental context, right? So if we wanted to estimate the effect of a treatment on an outcome, maybe it's, the effect of medication on, some health outcome. Ideally, what we would do is we would run a randomized experiment, right? So we have a bunch of people, we're going to randomly assign some of them treatment, the others are going to get the control, and we're going to observe their outcomes pre and post, right? This is the classic, the blue pill, the red pill. And to me, the key word here is random. Why is random assignment important? Well, it's important because we want to make sure that people are not self-selecting into the treatment, right? If they are, there's maybe something that's unobservable to us that is causing them to select the treatment that is also going to affect their outcome. And so this goes back to, issues of bias that we've been talking about the entire semester. Um, but random assignment comes, kind of washes all this away because, assignment is exogenous, right? Treatment is going to be purely exogenous. And so as a result, the differences in outcomes between the treated and the control are going to identify really the causal effect of the treatment. Okay. So that's ideally what we would like to do. Ideally, we would like to just randomize the treatment, let that take care of everything, compare them pre and post, and that's what we got to do. However, unfortunately, it's typically not that simple, right? So in economics, we rarely get to run randomized experiments or randomized control trials, also known as RCTs. Kind of really the main exception to this is in development economics, but outside of that, it's quite rare to see randomized control trials. So instead, what we see is we observe policies and treatments that are implemented or administered by some entities, right? Governments or schools or whatever it may be that are targeting specific populations. And so, because of this, and in general, it's unlikely that these treatments are going to be randomly assigned. So today, what we're going to be doing is we're going to be asking ourselves, well, how can we estimate the effect then of a treatment on an outcome using observational data, right? When treatment is not randomly assigned. Um, and I think as you guys can guess, the difference in differences design is going to be kind of one way that we can do that. Um, and I think this is really nice because what we're going to be doing is we're going to be looking at one group that is treated, another group that is control, and looking at them before and after, which is exactly what we were doing in this case, right? The only difference is that in this case, the treatment is randomized. In this case, the treatment is not randomized. However, under some assumptions, in particular, one really key assumption, we can argue that treatment is maybe as good as randomly assigned. And so what we observe then is a causal effect of treatment. Okay, big picture. I'll emphasize here that today, I say here we're going to work on we're going to focus on the canonical two by two case. What does that mean? That's a mouthful. By two, I just mean we're going to have two groups, treated, untreated, in two time periods, before and after. And that's going to make it really nice for us down the line. Okay. So what is the diff and diff estimator? Well, before I get into this, difference and differences, it's exactly that. I think it's really nice because I think it's really intuitive, as is often the case with really beautiful econometric techniques. The intuition makes a lot of sense. So we're gonna just take the difference in between the differences for the treatment group pre and post and the control group pre and post. And so really all we're doing here is, as I said before, we have two groups, right? We're gonna have a treated group where G is equal to 1, a control group, G is equal to 0, and 2 periods, right? So t is going to be equal to 0 in the pre-period. It's going to be equal to 1 in the post-period. And for right now, this y bar is just going to be the average outcome for some group G at a time period t. And our diff and diff estimator is just going to be taking the difference between the difference pre and post for the treatment group and the difference pre and post for the control group. That's it. That's all the estimator is doing. We're just subtracting two entities together, right? We're taking the difference between two other differences. And really what's the intuition here? Well, we're going to take the change over time for the treated group and subtract it from the change in time for the control group, where this control group is going to be kind of the counterfactual, right? So the assumption here, right, in order for us to argue that what we're observing is kind of a causal effect of the treatment, we need to make an assumption that this untreated group, this control group, is trending exactly how the treated group would have trended had it not received the treatment. This is kind of known as the parallel trends assumption. I'll get into that more in 2 slides. But really, the key thing here is it's really simple. We can do this by hand. We're just taking differences in means. That's all we're doing. But the key thing here is that we need to, be able to say that this untreated group really captures what would have happened to the treated group had it not received treatment. And if we can argue that, then these kind of simple subtractions uh, get us the causal effect of the treatment on an outcome. Okay, so what I've just shown, we can do by hand, as I said. However, we can also do it using OLS. And as somebody I heard in a talk say the other day, as economists, we're addicted to regressions. So I'm going to show you how we can kind of recover this DID estimand using a regression. Um, so how do we do this? Well, it's actually really nice. Remember, we're just taking differences in means. And so what we can do is we can regress an outcome on a dummy for whether or not the group is the treated group. Takes the value 1 if they are the treated group, takes the value 0 if they're the control group. A dummy for the post period that takes the value 1 if it's the post period, 0 otherwise. And importantly, the interaction between the two of them, right? This delta here. And so what I think you guys can probably convince yourselves of very easily is that these y-hats here are exactly these y bars that we observed on the previous slide. So, I'm not going to go through all of them, but if we want to look at the untreated group, the control group, in the pre-period, treat is equal to 0, post is equal to 0, treat times post is equal to 0. So it's just going to be alpha, right? This is the average difference between. I suppose this is really just the average outcome in the pre-period for the untreated group. And then, depending on whether or not you're looking at treatment or post or both, you're gonna, set this equal to 1, set this equal to 1, set this equal to 1. What you'll essentially find is all of these coefficients, when we rearrange them kind of algebraically, we can recover exactly this difference in differences estimator, right? So if we kind of do some manipulation here, what we see is that this delta, this coefficient on the interaction term between treatment and post, is exactly the 2x2 DID estimand that we showed on the slide before. So that's pretty cool, right? So that's how we would run the 2x2 diff and diff using a regression. So now all I'm going to do is I'm just going to probe at that kind of parallel trends assumption that I had talked about in the last slide. And I'm going to do this using two figures that come from Peter Hull's lecture notes on diff and diff. Peter Hull is a Wesleyan alum. Uh, and I think these figures do a really nice job of showing the parallel trends assumption. So in this case, we're looking at, I think these are gas prices for groups um, of gas stations, right, or companies that eventually merge together, right? So, maybe it makes sense that after companies merge, right, there's fewer companies, less competition, we can increase prices, right? Kind of follows. Um, so this straight line is going to be the treated group, and this dashed line is going to be the control group. And what it seems to us is that before the treatment, these groups are trending in parallel, right? So their gas prices are trending in parallel between the treatment and the control. And so as a result of this, it seems to me that it seems to me that it's a pretty good assumption, or at least not a bad assumption to make, that had this treatment group not received the treatment, it would have trended exactly as the untreated group did. And that is exactly the parallel trends assumption that we have to make with the diff and diff. So, as I said, one last time to hammer it home, had the treatment group not received the treatment, it would have trended in parallel to the control group. In this case, exactly as it did before it received the treatment. So, uh, here we see, a spike in gas prices, right? It seems to us that this is really where we could use a diff and diff. And, maybe it seems to us that at least graphically that these mergers led to increases in gas prices. Perfect. Okay. So we've gone over the diff and diff estimator, right? The DID estimate. We have now gone over kind of the main, in my mind, of course, there's other assumptions, but maybe the main assumption, the key parallel trends assumption. What I'm now going to do, the last two things I'm going to do is I'm going to put it into context with kind of a seminal paper in the field that actually introduced the diff and diff estimator, and then I'm going to show us how to do it in Stata. So this kind of all originates from a David Card and Alan Kruger's 1994 paper in the AER, where they try to assess the effects of the minimum wage on employment, right? So this is kind of the age-old question in economics, something that we go over in, Econ 101. They're going to test this empirically, right? And they're going to do this using a diff and diff. So in their example, there was an increase in the minimum wage in New Jersey. However, in its neighbor, Pennsylvania, or I should say, New Jersey experienced a rise in the minimum wage. Its neighbor, Pennsylvania, did not, right? So if we're willing to say that New Jersey, had it not received the minimum wage, would have trended, the employment in New Jersey, had it not received the minimum wage, would have trended in parallel to the trend of Pennsylvania's employment, then we can argue that what we observe in the data then is the effect of the minimum wage on employment, right? So here, the treated group is fast food restaurants in New Jersey. The control group is fast food restaurants in Pennsylvania, and the two periods are just, before and after changes in the minimum wage. Um, and so kind of the hallmark finding here is that the two do not find that kind of New Jersey's restaurant employment, they find that New Jersey's restaurant employment did not fall relative to that of Pennsylvania's after the minimum wage increase, which goes against the grain of what we would expect. And this kind of was the start of a literature that is still ever going, trying to better understand minimum wage, the effects of the minimum wage on different outcomes, and why does it affect employment in some cases and not in others. It kind of all really started here with the diff and diff. All right. So, anyways, so that's the Cardin-Kruger piece. I kind of felt like when you teach diff and diff, you kind of have to show where it all started from. Um, so now maybe what a lot of you care about, how do we implement this in Stata? Well, remember that all we're doing is, for the 2x2 case, we're just regressing treatment on posts interacted with treat and post. So that's exactly what we're going to do. And we're going to be using the well, I'll show you two ways. The first way is going to be using exactly the tools that we've been using the entire semester. So here, with the Cardin-Kruger case, we're just going to be regressing employment on the dummies treatment post, and importantly, as I said before, the interaction between the two of them that recovers this a diff and diff estimate, right? So, uh, this is another way to do it as well. So you'll see this sometimes in some papers. So I wanted to show it here. This is just, DID regress, dependent variable, our employment. The treatment is denoted by treat. In the Cardin-Kruger piece, there are different stores, right? There's different restaurants. So, but that's all this is saying here. Um, and then the time dimension, right? The post. Um, and so both of these, right, are going to give us what we want, right? This interaction term between treat and post. And so that's about it, right? That's all there really is to the diff and diff, kind of, 10,000 feet, overview. Um, just to reiterate one last time, I motivated this using kind of an experimental design, saying, ideally we would randomize assignment, but in practice, we can't do that, which can lead to some issues. But, if we're willing to make some assumptions, importantly, this parallel trends assumption, which is, the treated group would have trended in parallel to the control group had it not received treatment. Then, if we, take this difference in differences estimator, this kind of delta on this treatment interacted with post, then we can recover a causal effect of the treatment or the policy on the outcome. Lastly, we kind of went through two ways to do it in Stata, the same way we did before, and another one using a different command. Where once again, for the last time, sorry, I feel like I sound like a broken record, but really what we care about here is the interaction between treat and post. And that's it. As Manolis would say, that's all she wrote. I hope this made sense. I really appreciate everybody's feedback with on the IV video. Uh, I really appreciate it. Similarly here, this is my first time giving the diff and diff lecture. So if there's anything that's unclear or any, comments that you guys have, please email me. If it doesn't make sense, I would love to meet and we can go over it. But until then, I hope you guys take care.